it seems that we are live. Yeah. So I think the plan for action today is हमें जो हम हमारा ऑडियो विजुअलाइजर बना रहे थे उसी को और कंप्लीट करना है, उसमें प्रोग्रेस करना है. So just to look at what we did last time, here it is. We'll just run the project again. Okay, let's have some music playing before. Yeah. So this is the progress that we made. हमारा background Google Chrome में कुछ भी music play हो रहा है, and we are just taking the left and right channel, and उसका जो भी like peak volume या peak है पूरे wave का, वो हम बस यहाँ पे as a like rectangle का width जैसे हम दिखाने का ट्राई करें. Very basic visualization. Okay. Right now problem ये है कि this thing is running on single thread. That is some audio samples और जो UI है वो दोनों same thread में दिखाने का ट्राई करें. So if I try to like close this window, like it's not getting closed because we are not doing any event processing for the UI window. So we only close via closing the audio thread, right? So this was the first thing that I wanted to fix. Yeah, so I'll just open my project, and so yeah, so this is our current structure. So if we go to main, हम स्क्रीन का विड्थ हाइट दे रहे हैं, टारगेट FPS सेट कर रहे हैं, देन वी आर क्रिएटिंग द ऑडियो स्ट्रीम जो बता रहे कि गूगल क्रोम विंडो पे जाओ, उसका ऑडियो हमें रिकॉर्ड करना है. जैसे ही हमारा ऑडियो रिकॉर्ड जाता है हमें फ्रीक्वेंसी बफर मिलता है विच इज़ जस्ट द 2 चैनल्स एंड उनका पीक ऑडियो, एंड देन वी ड्रॉ इट यूजिंग Raylib. As you can see हम कॉल बैक के अंदर ही ड्रॉ कर रहे हैं, एंड लाइक सो देयर इज़ लाइक नो सेपरेट थ्रेड फॉर UI processing. And once we initialize the, so आगे बढ़ते हैं. कॉल बैक आने के पहले हमें ऑडियो स्ट्रीम स्टार्ट करना पड़ेगा. वो ऑडियो स्ट्रीम हम यहाँ पे स्टार्ट कर रहे हैं, एंड दिस इज़ द ब्लॉकिंग कॉल. सो जब तक हमारा यहाँ पे जो है टर्मिनल में जब तक हम कंट्रोल C नहीं कर देंगे तब तक वो ब्लॉक करके रखेगा. तो जैसे ही हमने यहाँ पे स्टॉप करा, कंट्रोल C करा, इसको सिग्नल मिला कि वी नीड टू क्विट. सो आगे वाला ये अनब्लॉक करके आगे वाला पार्ट कॉल हो जाएगा. सो यहाँ पे हम ऑडियो स्ट्रीम क्लीन अप कर रहे हैं, एंड लास्ट में हमारा UI का कोड क्लीन अप कर रहे हैं. सो या नाउ देयर आर 2 ways वी कैन मेक इट मल्टी थ्रेडेड. हम चाहें तो हम खुद की थ्रेड्स बना सकते हैं जहाँ पे हम पूरा जो ऑडियो को स्टार्ट एंड स्टॉप कर रहे हैं, एंड जैसे हमें UI से सिग्नल मिलेगा हम उन थ्रेड्स को ज्वाइन कर लेंगे एंड स्टॉप द स्ट्रीम. दैट वुड बी वन अप्रोच, and it's a very generic approach which would work for most scenarios. But in our case, since like we are working with this Pipewire library, it has its own concept of loop. So there can be at least 2 types of loop. One जो हमारी process, जो initial process जिस thread पे create हुई थी उसी पे run करता है, और another mode is जहाँ पे खुद की thread बना के run करता है. So like instead of like writing our own thread and managing it, we can just leverage that part. So if we just wherever we are like dealing with loop here, our main loop, so main loop run, main loop destroy, both and main loop quit. So all these have like similar versions. हमारे पास अब API में available है जो हम like which we can use to run this entire stream, audio stream, capturing logic in a different thread. So I think yeah, that would be my first go-to thing. And how did I found about it is, I think I went to one of these main loop thing. Do they mention thread somewhere? No. Oh, I think probably I'll just like so yeah, also I think I found it somewhere in the documentation itself. Let's not go over the process. I'll just start by like showing you the actual method. So pw main loop की जगह thread, come on autocomplete, why, oh we are in the wrong replace, we were coding the library, that was the problem. Okay, so basically if we go here pw.thread, so we are replacing our run function. So instead of run we have, I think, start here. And here you can see, like, this is the entire file which contains the looping logic, and here, like, you can read more about it. So basically this, if you look at this part, this says that the added feature in the threaded loop is to spawn a new thread that runs the wrapped loop. This allows synchronous application to use the asynchronous without risking to stall the Pipewire library. So exactly what we want to do. And here they have mentioned what things we need to do, which is different from main loop. So in our case, we need to create the loop using loop_new. We have to start this with this function, which is loop_start, and about destruction. So when the path is terminated, it has to be done using stop, which must be called without the lock. Okay. And once we stop the thread, then we can destroy it. So this is something which is different from the main loop, where we would just like creating it, starting it, stopping it. Here we have to like destroy as well. Okay, so yeah, let's go back. Okay, so I'll just do one thing. I'll just replace all the references of thread loop, main loop, with and let's see where are the problems. So yeah, thread loop start, this works. So yeah, I think the error is no matching function. Oh yeah, we need to change the type. So this also has to be same thing. So yeah, we change it from main thread to thread loop, main loop to thread loop. Fair hai. What else? I think we need to just save. We should receive thread loop, that is fine. And I think before doing that, we also need to do stop here. Thread loop stop, based on the documentation we just read. What else? Okay, and just to make sure that I imported the thread or not, so this is still the main loop, we need thread loop. So pw thread loop import, please import. So yeah, we imported the thread loop instead of the main loop. Now I'm not sure if this thing will work properly, but I just hope that it builds. So we'll just try building it. Yeah, it's not building. Let's see what's the error. Okay, thread loop quit is not the function, so we need to go there. Since we are not going to handle Control-C and all that, so I'll just ignore it for now. And where are we using it? Here. I'll also stop the signals because we don't want Control-C to do anything in this case. We'll have our audio thread handle starting and stopping it. So yeah, we can ignore this for now. What else? No matching function. What do you want? Oh, you want name as well. So yeah, let's name this as audio capture thread. Okay. Also, I want to point out what we are doing here. So let's see if our application is built or not. Okay, this is building. Next thing we want to do is we need to take care of UI thread, because you were relying on this part earlier. Now it won't work. Yeah. So this part will not block. We'll start the stream, will automatically stop the stream, and we are going to close the window. So I think nothing should happen. We should just see a flash of window. Yeah. So there are no errors as such, but yeah. Also PW stream destroy call from wrong context. What is this? Let's see. We are stopping PW stream. Probably we need to destroy the loop first, because this was a locking call. Let's see. Works. Yeah, because when we called this function earlier, it was like being called as soon as we from the UI thread itself, right? So, and stream is not in our UI thread, it's running its own thread. So moving it before we stop the thread works. Okay. Next is what? Now we need to run this thing. So just typical Raylib code, while should close window should close, and negate this thing. So this is our main UI loop. While user is not requesting to close the window, हमें like ये loop run करते जाना है. हम इस loop के अंदर क्या करेंगे, हमारा rendering logic आएगा. अभी rendering logic, okay, and we are just going to start the stream before we go into our main loop, and once we finish our like loop, we are ready to close, we are going to stop the stream as well. So this is the thing. Now next thing is moving the rendering logic here. Right now the problem is this on frequency buffer. Now this callback is also going to run on a different thread, which is different from a UI thread. So we cannot call all this here. So let's try this. If we build and run this, yeah, we got a segmentation fault. Segmentation fault because we are not running in the UI thread itself, where we have initialized our graphics and all. Okay, so we know for sure that this thing we need to move in our render logic. Let's create a function for that. A static function would work for now. Render instead of peak, let's just draw two rectangles for now, because yeah, we don't have access to peak values right now. So let's just call the render function. Okay, yeah, so now we have separated the threads. दोनों UI का काम अलग हो रहा है, audio sampling का काम अलग हो रहा है. We can have the actual program running, and if we try to request to close this window, our entire program should close successfully without any leakage, memory leaks. So yeah, I don't see any errors, so this works. Next thing that we have to do is actually rendering whatever we're getting here, like inside this. So again, the problem is we are sharing this data between two threads, right? I think one easy thing that we can do is we can just create this as a global variable. So if I do it like this, static float peak 1 comma peak 2, and we can then just access them here. Peak 1, let's make this peak 2, and we are writing it, this is from a different thread, so yeah, So this thing still works, but there's an issue. Like there are two threads which are like, trying to access this value. It works, and it's also like you can say very safe right now, because one thread is like only writing and another thread is only reading. Still, I think it still might be, it still might break in some scenarios. So like one of the easiest trends in working with like such trivial data types, we can just like make them atomic. So we are making them atomic so that at the language level itself, we're ensuring that these floats are only accessed by a thread at a time. So basically they are like accessed in a thread safe manner. So if I try to do this, oh, what happened? I might have. I think this is standard atomic, I guess. Standard atomic and then float. Yeah. So let's run this. Thing works, and it's safer because you made this atomic. Yeah. This won't work if we move to like little bit complex data structures such as vector, which we are going to, because our buffer is like this. But this is a good proof of concept. Like applications running on multiple threads, and they're communicating by sharing data, which is also thread safe. So we'll move this to FFT. Okay. So FFT. What is FFT? FFT is like you're getting an audio wave. What is audio wave? Any wave can be like represented, can be created by like doing sum of product of sine and cosine waves of different frequencies. So you can imagine any wave format, and we can just create those waves using sines and cosines of different frequencies. And so what we want to do is that once we mix this like sines and cosines to create the resultant wave, the process of like getting back the initial sines and cosines frequencies before we mix them, that algorithm is full Fourier transform. So this is exactly what we want to do. Like we are getting a mixed input from like our audio stream, and we want to pass it through a full this Fourier transform algorithm that will give us a list of frequencies, and whether like what and how much of that frequency has impact on the final stream. So with that we can figure out, okay, with this many frequencies, which one has like which amount, and we can just visualize that. So yeah, that's the next plan. So if we go back to this like where this is used, so that is audio stream.cc, and on process here, this is I think showing up on the terminal. We don't want to like deal with this as much, so I can just I think probably remove it. We can just remove it, and here we want to do the like full Fourier transform and get a float vector, and then pass it to the frequency thing, the frequency callback. So this is what we can do next. Okay, so let's do that. Control SN. So we can just like ask ChatGPT for this kind of algorithm in our case. So let's enter a prompt. So you want to create a function that takes audio sample as a float pointer array, and size of this array. It needs to return vector of floats after 50. Each float, I think it should represent the amplitude, and we need to do this in C++. Yeah, Python, 2 lines of code. Now we need CPP. We want to make this thing difficult for us. So they have returned us a code, so let's review it. So they have a dependency on this external library, got it, and perform FFT. It's getting the audio samples in the sides. It's creating a complex representation of FFT because cosines and sines, you can apply Euler's formula. E is equals to e to the power ix is equals to, I think, cos x plus I sin x. So basically complex numbers are good when working with Fourier transform. And execute the plan. Magnitude spectrum size by 2, I equals 0, I less than size by 2 plus 1, I square root of this. So where is FFT? Oh, this is the FFT result, and the size of FFT result is same. Somehow they're just getting only half of the string. So why did you divide? Why is the size of magnitude spectrum is size by 2? Okay, so got it. So this is the internals of FFT and how they are like giving the output of. I think next thing I want to ask is what is the relation between number of samples that we give and number of frequency we're going to get out. So if the number of samples are n, how many frequency information I can get? Frequency. Oh, it seems just like half of the frequencies we are getting, I think. Yeah. Okay. Anyway, we can take that into account while we are like outputting it. So let's just copy it. I think before doing that, we need to take this into account. We don't have this library, right? So let's just copy this code, and it should compile if we add this library correctly. So I'll just add it here for now at the top. Okay, and we'll add a library fftw3.h. Okay, oh yeah, it's not there. And if you try to build it, it should fail. What about Beaksman? Yeah. I don't want this, man. I want builder. Yes, okay. So we include the header, but we are not able to link it. So probably fftw3 is already in my include path, but I still need to supply the library. So if I search for package config fftw3, and I think I need a libs part. So yeah, I just need to get this thing added to make this compile. So if you're like manually running it by GCC, you can just add it as your C flags and it should work. But we are using CMake, so you have to do it differently using this thing. So we need to do similar thing, but for fftw3s, I don't like that we need to add it each time. Let's create a quick macro for this. So add lib and our lib name, package config search a name, and we're just going to add this macro. And what we are going to do, we are going to do this, and we are going to then add it and include the directories here. And I'm going to replace Pipewire with what is that, lib name, and okay, this I don't need, this I don't need, and I can add this thing separately, just the headers. So my macro should look like this. I'm going to create this new library. I'll try to find this thing out. So this thing should be my PC search value. Once I found it, I want to link the library lib name libraries and lib name include ours, and just ignore this part. Okay. Now once we added this macro, I can just instead of doing this thing individually, let's just comment it out for now. I can do add lib and do Pipewire. Second parameter would be lib. Basically I just need this. And this thing should work, I guess. Okay, we are still only seeing errors for 50W, so that's good. We're not seeing errors for this thing. We should also remove this, and so let's do this as well. So we'll search for fftw and fftw3. I'll just confirm this is what I type, right? Yeah. So not looking. fftw3 works, so it should work. Why is that not working? Do I see errors for Raylib as well if I don't do this? Yeah. So this macro works for Raylib, but it's not working for F50W. What am I missing? Am I linking the libraries or not? So I'll try to print the libraries as well. Let's see. F50W dot libraries. Yeah, I think this is what we get. Is it our code problem? Audio stream.cc. Oh, we forgot to import this thing. Oh, it's there. This does seem like a linker issue. Let me just rebuild. And CMake issue. Packet search. Tip name, audio visualizer. This is this. Just for 3 minutes, see if I will try this. Okay, maybe let's try manually adding the linker thing, right? So how do we do that? How do we manually add things to target link options? This is what you want. Audio visualizer and part to the library. So I think that is RG files, user include no libs lib, and then in this search for fftw. So it's in the folder itself. User lib and fftw3. fftw3. Okay. I think let me revert this entire thing what I did, the macro and all. So let's little space. Okay. Let's do it manually. Raylib fftw, calling it fftw3, and we are just adding the files. Those are fftw libraries, and where are we adding fftw include dash. Again, we don't need to add it per se. And find the reference. Oh, this is fftwf. This is fftwf. fftwf. Is that what I want? Like, is this the floating version which is not included? Audio stream. do think this is the issue here. FFTW3. Okay. I think I do have an older version of this project that I can look at. Cat code. Filing is correct. FTWF. So these are different functions. Let me try working with this. This does work. Okay, so yeah, the problem was the FFTW3 thing. So probably some, like, we have to link it some other version of it, and package config was not able to find it. Anyway, like, it's not worth worrying about that right now. So let's see what this function does. This gets an input array and the length. Yeah. It is initializing it. And so in that case, I don't want it to do anything. I just want it to be the length only. I think in our case, it's going to be length by a number of channels. Okay, let's keep it as length for now. And what we are doing, and we are just creating that and returning it back. So this is returning a double. Okay, I will make this a float. And okay. So now let's just call this compute. And input array and length. Okay, so in our case, input array would be samples and the size, number of samples. Okay, and let's go back to our UI code. So in the UI code, we were working with like just two values. Now we need by getting an entire buffer. So we need to have it here. So standard vector and the type is going to be float. This is our frequency buffer. That's it. And this is not thread safe right now, but we are just going to set it as that is equals to standard move buffer. Okay, so yeah, whatever buffer we received, we are just setting it here. Don't need to print this thread ID anymore. And now we have this buffer. Let's try to draw this. Okay, so size of the buffer is equals to buffer size, frequency buffer dot size. Okay, the canvas width is equals to get render width, and our canvas wide is this. Yeah, so this would help us in like drawing the thing correctly. So what I'm trying to think is I'm going to calculate like what is the size of it should be. Okay, so in our case size would be cell width, right? Each width is going to be the entire size, canvas width divided by the size. Also want to assert that canvas width is greater than size. That's the assumption we are working on. We need standard assert. Okay, and now for int I is equals to 0, I less than size I plus plus I. I'm going to draw the rectangle. So my x coordinate is depending on I into what is the size of my width. My height is depending on, so assuming the top left corner is 0 and I'm aligning everything by like from the bottom, all the bars are from the bottom, so it's going to be canvas height minus whatever the height of the bar is. So height of the bar, let's write it here, so height of the bar would now depend on whatever the frequency buffer size is. So that would be frequency buffer dot at and I, let's multiply this by 10. Just if it is too small, we should be able to see it at least. And I'm going to bar height. This is my width. Width is cell width and height is bar height. And color is red. Okay. Okay. Floating point exception dumped. So is this because you're trying to do this? Nope, not the issue. Oh, size by 0 could also be an issue. Size not equal to 0. If size equal 0 and just continue and do nothing. Yeah, because you don't want to have divide by 0 this as right? Cool. Assertion, this thing failed. Obviously it would be 0 initially. Okay, What is the size? You can pass an argument print, right, to this? No, just the expression. There was something that you can do. So this would be just size, I guess. I want to see what my size is. Just do it simple, man. Print it. Can't drop it off. Where is the size? Doesn't matter. Let's increase the size at least. Let's make it 2000. Oh, buffer is of size 2048. That's why it's breaking. Cool. So we just need a smaller buffer. I'll also make it 2048. And do something with that. Don't return here. Okay, yeah. So we are seeing the data, but it seems like it's symmetric. So yeah, first instinct is that I think it's 2-channel, right? Our data is, and we are showing it for both. Yeah, so we need only one channel while we are passing it to full Fourier transform, not both. So I'll just stop that, and what we are going to do is, let's go back to our audio stream CC, and let's just calculate. So yeah, this is number of samples, number of channels. Okay, so what we need is let's pass this information as well, number of channels, and we will calculate accordingly. So on single channel size is going to be length divided by number of channels, and so everywhere we are using length, we are going to use this. So channel size and okay. Now the use case. Now while we are traversing the input array, we just need to make sure that we take that into account. So for static const, this is this. I'm moving it by 1, right? and in our case it's I think going to be 2i. So 0, skip 1, then 2, then skip 3, then 4. Okay, since n is already half, it should be fine. Is there any other place we're accessing this? No. So this should actually just cut down our thing into half. And since the channels are interleaved, so 0th is channel 1's data, 1 is channel 2's data. So yeah, we have to skip 1 while reading. Okay. So at least this works better than last time. I do still think there's symmetry here. I think what is that? I think that's why we read, right? Because of the symmetry. So what was ChatGPT saying for calculating magnitude? We can use that. Yeah, so this should be the correct thing for calculating magnitude. So this should be n. I0 0 I0 square 1 1 square. Okay, got it. So yeah, this should also fix our thing. Okay, yeah, looks better. Yeah, so this is expected. Basically our our ears are more sensitive to this lower frequency range, so that's why you'll see a lot of music there and less on the end side, but it's there. I think one big thing that we can do is to bring this small thing, to emphasize the smaller ends, we can have a log while we are displaying. So bar height could be just logarithmic of, I think it's part of standard log or what? Yeah, standard log, and then to this just add 1 so that we don't have any 0 thing. So and now multiply something with this entire thing. So that would be into whatever my canvas height is, and just a little bit less than that. So just picking a random number for now. Oh, number was very high. Oh, I think we need to even this out. What if we half it? Even less, just 1/10. Okay, this still works for me. So yeah, this is the visualization that we have. Okay. We must be getting less than half of that, right? So Yeah, okay, this works. How does it look without visual? Oh. Should we experiment with the kind of log that we're using? What if we use log 2? How is this going to change? Without logs. Yeah, I think it looks better with that. I think another thing that we can do is we can experiment with the buffer size. So if I go to our audio stream and whatever buffer size we have, this is buffer size. Let's add a variable for this. Okay, buffer size. Const x per integer buffer size, and have a smaller buffer, because if you have smaller buffer we have smaller samples. If you have smaller samples, we have smaller frequency, like less frequencies, so our visualization should be more spread out. Yeah, I think that's good for now. We have like multiple frequencies in our so basically we are working with entire 512 frequencies. Next point would be to just bin it more into like a smaller frequency band, just 7 8 frequency, like bass, lower end, high end, mid, and all that, so we can have like a different kind of visualization here. But yeah, that's all I think